Hello, today I will be demonstrating the features of the EBIS-PIC 1D code. This code simulates the time evolution of ions in charge breeders that approximately have cylindrical symmetry, such as electron beam ion sources. This code models a magnetically compressed electron beam and an overlapping ion beam. Both beams are centered inside of a drift tube, and in real experiments the drift tube's length to diameter ratio is often very large, so it can be modeled as having cylindrical symmetry. This code is a one-dimensional electrostatic and magnetostatic particle and cell code. Atomic processes and Coulomb collisions are simulated using a Monte Carlo technique. The user interface is used to define input parameters that will control the simulation. Once the input parameters have been set, they're saved in an input file, and simulations can be run using this input file. Once a simulation has been started, plots of the data generated by the simulation will be constructed. The user interface has 4 windows: a diagram of the device cross-section, an information window, a console window, and tabs for input and output. The information window will introduce you to concepts behind the code and give descriptions of the input parameters you will set, and that's located right here. The diagram window provides a graphical way of visualizing and interacting with the input parameters. The white circle here represents the drift tube, the green circle the electron beam, and the red circle the ion beam. By clicking on a part of the diagram, you'll be taken to a corresponding input parameter. For instance, by clicking on this drift tube, you're taken to the atomic number of the background gas. So there are several tabs of input parameters. By clicking on a tab, a description of the parameters it contains will be displayed in the information window. Clicking on a parameter's label will also bring up a description of individual parameters. Here in the physics tab, we have the flags that control which atomic processes in physics will be included in the simulation. In the device tab, you control the experimental parameters related to the device. In the species tab, you control the parameters related to the background gas, the electron beam, and the ion beam. In the numerics tab, you control things like the numerical grid spacing, the time step, the number of MPI tasks when you're running in parallel, things like that. In the post-processing tab, you'll find controls over what data will get saved and how frequently the code will save the data. In this user plots tab, I'll get to later. Okay, so when you are finished inputting the parameters, you can save by clicking on this, or if you have already saved, in the case that I'm going to present to you, I've already saved a input file. You can open that file, and then to run the case that you've selected, you click this run button, and when you're running the simulation, it will produce output in this console window, and as it saves data, the data will be presented in plot tabs that will appear here. The number of plot tabs that appear depend on what you select in this post-processing tab. So we've generated radial plots, radial profile plots such as the electron density, ion charge density, the electrostatic potential, and the radial electric field. In the counts tab, you have time-dependent data of the number of macro or computational particles that you're using, and the final charge state distribution. Under the Averages tab, you'll find time history data of particle averages. So, for example, the average perpendicular particle energy or the parallel energy. Under the Profiles tab, you'll find radial profiles as well as velocity distributions. Now, the output is saved as a binary netcdf format, and it's recommended that you use third-party data visualization tools to construct figures for publications. However, we provide these plotting tools as a convenient look into the data. And in addition to these pre-selected plots, you can create your own plots in this User Plots tab. When you click on this Create New Plot, it brings up a dialog that you can enter what data you want to be plotted, as well as the plot title. And once you've selected what data you want to plot, you click OK. I forgot to mention, in these other plots, you have control over the view of the plot by using these buttons in the toolbar. So you can zoom, you can drag plots, and you can save plots. And when you click on Save, it will save each of the tabs as its own figure. So the final plots will generate one figure that has these 4 plots in it. And you can save in PDF format, EPS format, PostScript, JPEG, PNG, just a very large number of formats are supported. But in this User Plots, each plot that's constructed has its own zoom and drag tools, and as well as like a reset button. So for example, if I want to zoom in or drag, I do this, and then if I want to go back to the initial view, I'll click on the Restore. And then you can save individual user plots, you can delete individual user plots, and you can also edit the labels, and you can add additional data to a single plot, or remove added data by clicking on this subtract icon. Alright, so let's see if I've missed anything. I think that does it for this introduction to the EBIS-PIC 1D code, so thanks for watching.